managing this room. Okay, I'd like to introduce our presenter today, Dave Couch, my husband. He was the Senior Vice President and Chief Information Officer for 22 years at Spartan Nash Corporation, where he was responsible for all business systems, technical infrastructure, and communication technology. Dave has over 50 years of experience in information technology in retail, wholesale, and manufacturing organizations. He holds a BA and MA degrees from the University of Arizona. I would also like to add to it, he's also a member of the Holland Board Power, BPW, Power Works, Power and Water, BPW was it? Board of Public Works, okay. He represents the 4 townships surrounding the city, because we do not live in the city of Holland, but he's a member of it. He's always had a huge interest in electricity. So electric cars are right up his alley. So I'm going to turn it over to him.
Thanks, Sue. Can everybody hear me okay? Good. Okay. So you bought a car, or are you planning to buy an electric car? Living with electric car is different, and it's wonderful, you will find. But as my wife likes to say, it's all about the charging. Is once you get the car, how you're used to going to gas stations, but now it's electricity that you want, and it's different. And once you get accustomed to it, it's like you've always done it, but it's different. So that's what this presentation is about. So let me see the various devices here. Aha, works, good. So we're going to talk a little bit about electric vehicle system components. We're going to talk about types of chargers and what it's like, how to set yourself up for home charging. We're going to talk about charging on the road. It's very interesting. A lot of things going on there. And then we're going to talk about some tools. And both tools that you may have that comes with your car, or external tools that you might want to use to keep your car charged. So, and then ask questions anytime. I have about 70 minutes of presentation, at least as I've timed it. I usually practice these things a few times. So anyhow, feel free to ask questions. So let's talk about electric vehicle components. So obviously there's a battery system. Typically in today's cars, you're sitting on the battery. It's built into the chassis in a couple different ways. Oh, and by the way, just as a point of reference, we are all electric in our house, but we're Tesla. So any experience that I share will be with Tesla cars. So just, not that I'm biased, they're great cars, but there's a lot of great EVs out there. But my reference is going to be from Tesla. So we have an X and a Y. And the battery system actually is different between the two. The Y is very much integrated in the chassis. The X, they developed the X when they were experimenting strategically. Tesla was trying to decide if they were going to have replacement batteries on the road as opposed to charging. And so actually the way the battery system on our X is manufactured, there's 4 attachments on the 4 corners, and cable attachments. And if you undo those 4 things, the whole battery system will drop out. And which I don't advise, and I've never looked at, but as you look at videos and understand how they're built. So it just happens to be that the Tesla X design was during that period of time when they were trying to decide how they were going to charge electric cars. There's traction motors. Typically, if you have an all-wheel drive, you have 2 motors, one on the front axle and one on the rear axle, you see in the diagram. If you have a front-wheel drive, you're going to have 1 motor in the front, or if you can have a rear-wheel drive, you have 1 motor in the back. There's various control systems. We'll talk a little bit about. There's a battery management system, and that's a very crucial component, which we'll talk about later. There's an AC to DC converter, and we'll talk about that. That's used in 2 types of charging and not used in the third. And then there's various accessories, air conditioning, heating, radios, music systems, and so forth. And one of the things when we get into mileage, you'll find you can experience different mileage based on what accessories you're running and the time of year. And my wife and I have done some very, after a panic that we were going someplace and we were little borderline on how much energy. So we turned everything off but the car, and what a difference it made in the mileage. Anyhow. So you hear about range anxiety. In range anxiety, I think this graph perfectly depicts what you think about before you buy the car and after you buy the car. And so there's two concepts. If you look at the graph, the range anxiety on the blue line is for long trips. And that's the biggest concern, is when you take a long trip with electric car. So how do we get the electricity in? How does all that work? And then versus day-to-day driving, not a big deal. And when you'll find once you get an EV, normal daily driving is not a concern because you charge at home. So if you look at this, basically it says 2 years before you buy the car, when you're still trying to think about it and so forth, and before you've learned all the details about how the cars work, you're quite concerned about the range. And then you get to the point when you buy it, and then after you've experienced it for a while, you realize it's not a big deal. And so it's a lot of the range anxiety is for folks that aren't as aware and haven't educated themselves and understand what the nature of the car is. And I just thought that graph really depicted, because even and I wasn't overly concerned with range. My wife was more concerned, but as we've learned and as we've used the car, you realize it's not a big deal. So what determines the range? Well, the vehicle weight. We have 2 Teslas. One's 4,000 pound, or let's see, one's 3,000 and change, and the other one's 4,000 and change. And they get different mileage in terms of the amount of electrons it takes to move the car. Motor configuration. Is there one or is there 2 motors? And regeneration. And regeneration, we're going to talk about this in a couple different times. Your motors on your axles act as a motor in one mode, but they can be switched to be a generator in the other mode. So when they're in the motor mode, they're pushing the car forward. When you get to the point, what you learn is in an electric car, you don't coast. When you take your foot off the accelerator, depending on the electronics of the car, the motor becomes a generator. And then the process of generating electrons provides a drag to the car. And so you wind up being able to slow down and not have to use the brakes. And you'll learn over time that in our cars, for example, 95% of the time when you would use a brake in the past, the regeneration of the car is what's slowing the car down. So and like I say, maybe 5% of the time, once you learn the car, that's the only time you're actually using the brakes. Battery characteristics, how big is it? Outside temperature, they are not as efficient in the cold weather. You get about a 20% degradation. The driving environment, do you drive 70 miles an hour? Do you drive 80 miles an hour? Are you doing city driving or highway driving? In general electric cars, city driving is much more efficient versus highway driving. And the difference between driving 78 miles an hour and 70 miles an hour makes a significant difference in the range of the car. And then accessories usage. Air conditioning in the summer draws on the battery, and different car manufacturers, some use heat pumps, they use different methods. Heating in the winter, all those things have an impact on the range. So Gary did a fabulous job on batteries. I'm not going to spend a lot of time on batteries. There's different technologies that are in use, and there's many technologies that are underway or in development that are going to come onto the scene and going to make big differences. I'm not going to spend a lot of time on that, but you can see the nickel metal hydride and hybrids, and in plug-in hybrids are very common. Lithium, although it depends on the model and the manufacturer. Lithium ions, probably the most common, and then LFP or lithium ion phosphate. There are now cars that are being manufactured with that type of battery, but there's a lot of them that are coming on the scene. There's a lot of folks that are on development, or a lot of products that are under development. Gary talked about that in detail. I'm not going to spend a lot of time there, but there's always been this discussion of raw materials, and in fact, a lot of the raw materials are in other countries. And so our country is now working at there's a lot of the raw materials that are available in this country, or I'll say that are in the ground. And so there's a lot of action going on to build mines and figure out ways to get those raw materials out. But the problem is there's a very long lead times to developing those mines and processing facilities. So another big topic is recycling batteries. About 95 to 98% of the critical materials can be extracted from a recycled battery. And I like to use the example in Reno, Nevada, where the Tesla's Gigafactory that's been there for quite a few years now, not one of their more modern or not one of their more recent implementations, but there's a recycling company that's right next door that recycles batteries. And so oftentimes, most of the Teslas that you get today have recycled materials in the batteries. But there's, as Gary talked about, there's several companies working on solid state batteries, other chemistries and so forth. They're playing with higher voltages that generate faster charging times. We'll talk a little bit about there, but that's all I'm going to cover in batteries. This could be a topic, a full topic that somebody could cover. So the batteries, and how do you get energy in them? So there's two ways. It's an internal source or this regeneration that I talked about, where your motor turns into a generator. So today's EVs consume about a quarter of a kilowatt hour to a half of a kilowatt hour per mile. Again, depends on how you're driving and so forth. Based on testing and the data I've collected from our two cars, our 5,000-pound Tesla X gets about 3.6 miles per kilowatt hour. Our 4,000 and change Tesla Y gets about 4.2 miles per hour. So the lighter weight, it doesn't take as much energy to move the car. And then most systems today are 400 volt, but there's typically higher end cars, your Porsches and some of the others, the high end products, they're now working on 800 volt systems. There might be 10% of the cars that have 800 volt systems. And if you have a charger, a 350 kilowatt charger, the charge times are dramatically less. But again, all this is going to be changing over the next couple of years. So I passed out an eye chart to everybody, and for those online, we'll email the eye chart to you. I was looking for good information about the battery size, and I found this online source of information from Inside EVs. What I thought was interesting is just to look at the different battery sizes. Just have a Mini Cooper. It has a battery that's only about 29 kilowatt hours, whereas you get up to a Hummer or an Escalade and it's 200 and plus kilowatt hours, much larger batteries, because you've got more weight to move and you've got more accessories and so forth. So I'm not going to spend a lot of time on this, but the eye chart that I passed out has battery sizes and has a lot of other information. But my original, when I was going for trying to find this thing, I got the data. It has a lot of useful information. So I thought I'd pass that out. And I have that available in Excel if anybody wants it. So then talk about charging speeds. And this is just a cross section of cars. And so what the chart tells you is the time to get from 10% to 80%. So you hear about this a lot, about 20% and don't go above 80% and so forth. The reason is that the 80%, the top end, is when you do that last 20%, the charging is much slower. And somebody had a great analogy. When you go into a parking lot, if it's 20% full, finding a spot in the parking lot is pretty easy. Doesn't take you much time. If the parking lot is 80% full, you're going to have to drive around and find out where to find an open spot to pick that car. Same thing with the electrons. I mean, the physics are different, but the same concept is true in that as you're pushing electrons into the battery, the more full the battery gets, the harder it is to find a spot to put the electron. I mean, again, analogy, but so that's why people always talk about charging to 80%. And if you look at all sorts of statistics, they always talk about How long does it take to get from 10 or 20% to 80%? Because typically that's what you do. In batteries, it's changing, but traditionally batteries, when you go, the more you go to 100%, the harder it is on the battery. So for example, when we drive, when we take a long trip, we charge the night before, we charge the car to 100%. Then we're on the trip. The rest of the time, we charge it to 80% because of time, so that you get the battery charged faster. And our normal day-to-day driving, when we plug in the car, plugged in my car last night, and I set it to, we set it to 80%. And so that's why you'll tend to see those numbers. So the miles recovered, the max power, we'll talk more about that, makes a big difference. But you can see on the low end, you see about 9 miles per minute. On the high end, you see about 16.3 miles per minute. And so I just thought this was kind of an interesting chart. We'll talk more about this when we talk about the different types of chargers. So anyhow, so let's talk about charging. We're going to talk about the types of chargers and talk about the standards. So there's 3 levels. The first one is called level 1. And basically it says you're plugging the charger into a standard 110 outlet in your house or wherever you are. So there you have about 15 amps available to you. And so you're going to get, in our case, we get about 4 miles an hour when we just plug it in to a standard outlet. If you own a car, you're going to want to put in a charger in your house, in your garage. And so typically what that is, where the standard outlet is 110 volts, what you're going to put in is a 220 volt or the voltages vary. And depending on the type of charger you buy, and I'll show you some different chargers, it's going to be around 60 amps or more. And so you get anywhere from, 2.5 is pretty low, but typically 6.6 kilowatts or more is the amount of energy that's available to you. And so the charging time varies depending on the size of the breaker and the capability of the car and so forth. But for example, in our house, we get about 40 miles an hour with our 220 volt charger, and we charge it up at night when the rates are low. We'll talk about that a little bit later. And so when we're up in the morning, it's 80% ready to go. So then there's what's known as level 3 or DC fast charging. So in the first 2, it's AC that you're providing. In the last one, you're providing direct DC to the car, a direct current, can be over 100 amps. And depending on the charger, your load is going to be anywhere from 50. That's a very low end, slow level 3 charger to 350. And the question is, in the case of 350, can your car accommodate that? Our cars and the Teslas that we have, the max that they can do is about 250 kilowatts. Every car is different, and that chart will tell you about that. And so depending on the optimization of the car, you can get 80 miles in 20 minutes. Actually, you can get more than that. That statistic's a little old. But anyhow, we'll talk more about that as we go further. But 3 levels, 1, 2, and 3, and you're going to live basically with 2 and 3. At home, you're going to have a charger that's level 2, and then on the road, it's level 3. Okay, so a little bit about that. So I mentioned there's an onboard charger in the car, and that is used for level 1 and level 2 charging. So it's doing the conversion from AC to DC to go into the battery system. The batteries are direct current, and it goes to the battery management system. And the battery management system controls and manages the temperature of the batteries, the influx of energy. It does all that management for you. So for example, if you have one type of battery, the battery management system is going to have the parameters for that type. If you have a different battery system, a different type of technology, the battery management system controls for those characteristics. When you're DC fast charging, the charger is basically on the pad that you're connecting up to. It's taking the utility feed, converting it from AC to DC, and depending on the type of charger, The charger might be able to do 150 kilowatts, 70 kilowatts, could be all the way up to 350. We'll talk more about that in a minute. So that direct current goes directly to the management system, doesn't go through the charger in the car. It goes direct to the battery because the battery system is a DC system. Connectors. So level 1, standard plug like you have at home. Level 2, if you buy a US, in the common connection in the US is a J1772. I don't have a good example of it, but this is what the connector looks like. Or it's a Tesla connector. And the Tesla connector came out and was designed before, was the first one designed. It's very effective. And so to do level 2 charging, either at home or on the road, you're using either a J1772 or a Tesla connector, or what is now known as NACS, the North American charging standard. We'll talk more about how that happened. And then in the DC fast charging world, there actually were 3 different connectors. CHAdeMO was an older style connector that was, I think it was with the Leaf way back when. It's no longer, I don't believe anybody is producing a car with a CHAdeMO any longer. And so then the next one is the CCS connector, which is the typical what you see with American cars, at least made up till now. And in Europe, it's a CCS2. In the US, it's CCS1. And then there's the Tesla connector, or what's now called as NACS. The difference is if you look at that CCS connector, that top graphic with the round and the oval down below, the round portion is actually a J1772. So if you have an American car and you have a CCS connector on the side of the car, the upper portion of the car is for J1772 if you're a level 2 connection. If you're at a supercharger, then you have the larger connector you see down at the bottom, and those bottom 2 poles in the graphic, those are for the DC a high power connection. So, any questions so far? Yes, sir.
Tom.
If you want to get a non-Tesla go to a non-Tesla charging station.
Yes.
What would you recommend for the purchase of a adapter?
So I have the Tesla adapter, which this is CCS1 on this side and a Tesla connector on the other side. There are other non-Tesla brand connectors. This one is what I've been doing this for a while, and I looked at all the other ones, but when Tesla said they were coming out with one, this is what I bought. So if you want to have the most flexibility, you want to have one of these.
Okay, from Tesla.
From Tesla. Okay, so let's go a little further. So North American charging standard. What happened a couple of years ago was Tesla took their standard and they released the specifications for that standard and made it available to everyone. And the graphic on the right-hand side shows you all the brands that are now planning to support the Tesla or NACS connector. There's still a few of the high performance folks over in the upper hand right that haven't adopted it yet. Now, some of them they will sell you because they haven't manufactured them this way yet. And I don't know where each individual manufacturer is at a different state of development, I'll call it. And so many of them will send out adapters, 4 different companies have sent out adapters. Now I've heard from different people that we're still waiting for ours. So people have gone out and you can go buy an adapter from a variety of, Electron makes one, there's a number of good ones. And so some people have resorted to get their own. So anyhow, so the adoption, when we get a few years from now, this will all be sort of a mute discussion because everybody will be using at least it appears that everybody's going to be using the NACS connector. So what this allows you to do is allows you to get to the Tesla charging network, and I'll talk about charging networks later. And so automakers are adapting NACS. And then Tesla has created a magic dock. And what it is, when you'll see, and we have a guest presenter here that's going to be talking about charging in a Tesla location. But what they do in some locations, they have a particular type of charger that's has both the CCS1 and the Tesla connector. And you go up and you grab the button, and if you hold down the button, what comes off of the connection looks like this. If you just hold down the button for a second and pull it off, it looks like this. And so it's a mechanical interface of having both of these devices in the charger, in the stand. And so depending on how you pull it out, you get one or the other. There's only 2 in Michigan. There's only 80 of them so far, so I don't know how far they're going to go with this. And in Michigan, there's 2. One's in Mackinac City and one's in Ypsilanti. So, but it's, yes, sir.
With that new type of Tesla charger, do they address the short cord problem? That is that many CCS cars have their charging port on the left side front fender, but Tesla puts all their ports on the back end. So you either have to occupy 2 stalls. Yep. Or you have to find a longer cord. Does Tesla provide the longer cord now?
In the ones that are in the videos that I've seen, I have not experienced the Magic Dock directly. But in the ones that in the Magic Docks that I've seen, it does not change the cable size. Now there's a version 4. I didn't include a graphic of it of a type of Tesla connector stand that does have a longer cable. I don't know how far that rollout is. All this stuff is very much in flux. And so, but what Gary points out is a very good point, that the placement of the connection in your car has a lot to do with how easy it is to get to where the cables are, because the cables in well, and you'll see when Bill does the demonstration here, the cable that is on a Tesla charging station is very short. And people make extension cords. There's all sorts of things that you can get involved with. But and you'll see people, they'll back their car in kind of a funny way to get the connector up close. There was an example where somebody, one side of the connector of certain slots were used, certain were not. And so this person figured out that they could go to the backside because there were parking spots on both sides, and then they were able to orient their car to make the connection. So it's that is definitely an issue. So let's talk about, okay, so that's the connectors that we've seen about the different types. Let's talk about the reality of setting up your home for charging, and then we'll talk about commercial offerings. So, and this, I'm going to tell you my recommendation, but there's lots of options here. So on one side, you've got your breaker panel on the left. On the right-hand side, you have the charger of your choice. And I just put a few up there. My recommendation is that you should directly wire select a good charger and have it directly wired to your electrical panel. Now, that varies from house to house. How far is your electrical panel from the garage? Some people, it's in the garage. In our case, we had to run a bit of cable. So there's a cost there, but I think that's the best solution. So you can, and I'm going to show you a chart of different types of chargers. And so you can see the chart on the lower left-hand side, depending on the size of the circuit, the circuit breaker that in the cabling that you install, determines what kind of miles per hour you're going to get on your charger. And in the National Electrical Code, there's a 20% margin. So if you put in a 60 amp circuit, you're actually going to get about 48 amps. And so like we have a Tesla connector that's shown over there in the middle. We have a 60 amp breaker, but the actual draw is about 48 amps because of the electrical the rules, how they design stuff in terms of what the standard is for breaker size and versus the load. Another option shown in the second middle graphic is if you have a dryer connection, a 220 volt large connection in your garage, you can buy these chargers that instead of being hardwired, you can plug them into the wall and plug them into a dryer charger. And there's some different types. We're not going to go into all that, but I recommend having them direct wired. Yes, sir.
When I put my charger in, I have a 50 amp breaker.
Mhm.
And when they got done, he said, okay, we're all set. We got a 60 amp breaker in there. And I said, well, wait a minute. The spec says it has to be 50. And he said, well, that's not what they were telling us. But I got it right straight from consumers. So he changed it back out to a 50 amp. And then I got a message from consumers that said, please set your charge rate to 40 amps and take a picture of it that you've set it that way. And so now my charger is set for 40 amps. Why is that?
That has to do with consumers' charging program and how they're. I don't know if you're getting reimbursed. If you've gone down that path.
So I'm getting the cheapest. I'm getting the super rate, which is from 1 o'clock till 6 o'clock, and it's 0.08 or 9. I'm not sure what happened there.
Okay.
But it's, as far as they're concerned, the best they can give me. So that's what I got.
Do you know what size service entrance you have coming into the house?
100 amp.
100 amp. Okay. I don't. I'm surprised. So when we put in I did not interface with consumers because they have a rebate, a charger rebate.
Oh, I did that.
Yeah. Well, they want wireless access to your charger to monitor what you're doing.
I didn't give it to them. They they gave it to me anyway, but I don't have, they're not in control of my system. So
Okay.
well,
Anyhow, I didn't do any of that.
uh-huh.
I did it on my own. I told them that I was putting in a charger because they're concerned about the transformer capacity in the neighborhood kind of thing. But I have a 60 amp breaker and specified by Tesla in the charger. And there's a setting in the charger to configure how it's been installed. The wiring is all for 60 amp. I think it's number 6 wire. And on the car, when I'm charging, I get 48 amps a leg.
Yeah,
So
that's the standard with mine is it comes up 48, but
it does.
it's been adjusted to 40. And I see them both. So I don't know exactly what's going on there.
Yeah.
But I'm pretty sure I'm being charged at 40.
Okay.
My wiring is for 60 amp breaker.
Okay.
So everything's fine though. It works great, charges plenty, and I have no problems.
That's great. Yeah, your particular situation, I don't know all the factors, but anyhow, we did it on our own and so it's worked out okay. That's our configuration. Yeah, junk in the garage. You're on the tool wall. So home charging and the rates, so there's the energy rates, but you have to also calculate, there's 2 numbers that you have to be concerned about. In the utility business, it's called ready to serve, and the distribution cost of the wires coming into your house. And then there's the actual kilowatts. I suspect that your number is the actual kilowatts and doesn't count the cost of the wire to your house. If you look detail the rates. So if you look at the combined rate, currently it's at, depending on whether it's fall or winter or summer, it's 14.8 cents or 15.1 cents. In our Tesla Y, that's good for about $1 for about 30 miles. On our Tesla X, it's more like 25 miles because it takes more energy to drive the car. The Holland Board of Public Works, their rates are significantly less. And that's why they exist, about 9 cents per kilowatt hour. So on our Tesla Y, that would equate to about 47 miles. So there's a significant difference between whether you're covered by consumers or a BPW. The speed of charging depends on the starting battery charge. We talked about that, the speed of charging before, the temperature of the battery. Our day-to-day processes in general, we connect. Now, it's my wife and I have different habits. Some of us are more conservative than others, but in general, connect to the charger when it's going to be below 100 miles on the battery. Normally, we set to 80%, as we talked about earlier. And we moved to 100% before a long trip. And so you're got a full charge in the morning and ready to go. So anyhow, a little bit about our experience. These are the chargers. I've updated this graph over the years. These are sort of the current ones on the market. So Ford, for the F-150, they produced a Charge Station Pro, which has a capacity of 80 amps. So you get a lot more energy through that. And then in the general marketplace, other than that exception, there's the higher power or what are generally referred to as medium. They're generally referred to as higher power. Those are the ones in yellow. And you can see some of them have the NACS can either get the 1772 connector over there on the third column from the right, or some of them have NACS. But those are good brand chargers. And then the lower powered chargers down below. Now, what's interesting is I got in the mail just before coming to earlier this morning, that NLX, which you ever seen juice box chargers? They've are ending their business in the car charging. And so as of October 11th, they're no longer going to be producing. We'll see if juice box, if the actual charger continues, somebody picks it up, because and you tend to see them in more low end situations like campgrounds and whatnot. But NLX, they're getting out of the business. And so we'll see. Charging on the road. So there's two types of chargers on the road. There's level 2, where generally called destination chargers. And there's level 3 or fast chargers. Or superchargers. There's charging networks, and we'll talk about availability in the networks coming up. So level 2 chargers, often referred to as destination chargers. You typically find these in hotels, by municipal buildings, like downtown by the city, our city hall. They have some level 2 chargers there. You see them in campgrounds, in marinas. Sometimes businesses will install them for their employees. And some are offered for free, and some are they have a charge. And sometimes they're owned by the entity and not part of a larger network, and some of them are part of a larger network. The speed of charging on level 2 varies widely. We've seen anywhere from 16 miles an hour, in other words, how fast you gain mileage in the car, up to 440 miles an hour. 40 miles an hour is pretty rare. In fact, our experience is we've seen a minimum of, I should update that. We've had one that's been 16 miles an hour. The max we've seen is 45, but I averaged it up over the data that I have, and we see in general about 34 miles an hour for level 2 chargers on the road. And what we've also learned is it depends on either how much money they spend to wire them up, or how they've wired them. And so, and I've got lots of stories about that, but I don't want to take too much time. Susie?
Are there very many free charging in Holland?
Yes, there are. And I'm going to talk about those in a few minutes.
Okay.
Yeah, I've got some when I start showing tools, I'll show you some of the things around Holland and some places where they're free. So here's some examples of the various chargers that these are basically all chargers we've used in different places. In the upper left is that's a municipal, and they wired it wrong, quite frankly. It has 2 connectors. If there's only one car, you get 36 miles an hour. If there's 2 cars, you get 16 miles an hour. And so, because they didn't want to spend the money to wire it up, what I call wiring it up properly. And then the lower left here, that's up in not Rose City, Boeing City. That's ready. When I talk about the charging networks, that's a company out of Detroit. I wouldn't normally talk about them when I show you the different networks, but because they're around Michigan, I thought it would be important to include them. That second one from the left on the lower deal, that's a charge point. That is by far the most common level 2 charger you're going to see around the country. They have an enormous number of these installed. And then just above it is a Rivian charger. That is in a state park. And you'll see in a minute, we're going to talk about our state, state of Michigan has a program where they're putting free chargers in all of the state parks. Holland State Park was the first one to be installed. There's 4 Rivian connectors out there. It's properly wired. You get high 30s miles per hour. The point that's my wife just mentioned is that when they close down the Holland State Park for the winter, they barricade. There's like 2, and there's the main parking area, and then there's a parking area around the other side of the concession stand. And they close that off in the wintertime. The chargers are over there. And so anyhow, I don't know what the plan was there. Then anyhow, on the top level, the third one over from the right, that's a Blink charger. The third one over the right on the bottom, that's a private charger, not part of a network. Upper right, the upper right corner, that's a amp up charger. You present your credit card or be part of the network. You can see there's 2 white connectors hanging off the top, and it's got a recoiler. Those are J1772 connectors. You pull it out and plug it in your car. I think that was out in Connecticut where we found that one. And then the one on the right, that's a Tesla connector on one side and an L connector on the other side, or in case, sorry. And that's free. It's in a parking lot up in Mackinac City at the marina. So anyhow, all different types. And there's more than that. That's just some examples. Level 3 charging on the road. Tesla has a very well-developed network. It's one of the best in the country, and that's what's been driven NACS. A couple different things. Tesla was one of the first people to come out with cars, and they realized that in order for them to be viable, they had to have a robust network. So you'll see when I show you the numbers, they have connectors all around, or chargers all around all around the country. Others are trying to catch up. The government funding is helping, but it's being complicated by political infighting. One party doesn't want to support electric cars, and the other one does, and blah, blah, blah. But the key issue here is they funded it through the states. So they gave the money to the states, and the politicians say, well, they put all this money out and there's only 17 live chargers. Well, that's true. But the problem is they gave the money to the states, and the states don't know how to deal with it. They don't have the infrastructure. They haven't thought about it. And so they're all trying to scramble and figure out what's going on. And so that's why the real problem exists. There's a lot of networks that are partnering with established companies. So Blue Oval from Ford, they've partnered with these different charging networks that we're going to talk about, that they have available on that network about 111,000 locations. So they're probably connectors. I don't know that for sure. And then Iona Network is a partnership. They want to build 30,000 locations over the next few years, and you can see it's a consortium of a number of the car manufacturers. So there's a lot of stuff going on here, and if you're not driving a Tesla, you have to be strategically thinking, and I'll talk about tools when you want to take long trips. So charging on the road, typically these level 3 chargers on a low end, you'll see about 50 kW. That's a terrible charger, but some of them are that low, all the way up to 350 kilowatts. Now our Teslas, every car is different. Our Tesla can only take in 250 kilowatts. And the Tesla chargers actually will do about 350 or 325, but they're all throttled down to 250 because all the Tesla battery and car infrastructure at the moment maxes out at 250. And so what's going to determine what you find when you show up? And My wife doesn't let me experiment anymore because we've driven around the country and I'm always, oh, I haven't tried this one. And so she, go to Tesla. Yes, ma'am. So anyhow, and we do. It's just as I was trying to learn, right, different systems. And so I could talk about this stuff. Plus my philosophy when we bought these cars was I didn't ever want to be in a position that I couldn't get a charge. So I bought adapters, and so forth before, early on. I have a CHAdeMO adapter. I used it maybe twice in the first year, never used it since. I didn't even bother bringing it in. So I've experienced, if I find a new one, oh, Sue, we got to go over this. Do we have to? Anyhow, and I'll talk about one here in town that I recently discovered, and you don't ever want to go there. So depending on what kind of utility service is available and what they want to invest in the equipment determines what kind of charging station you're going to see. And some of them are dictated by the network and some of them are dictated by the owner and what they want to invest. And you can tell people, you can kind of tell whether they care or not. It's my opinion. And then 400 versus 800 volt, like I say, we talked about that before. Some of the cars that do support it make a difference. Supercharger rates are higher. Typically what you see, whereas at home, I talked about the cost per mile or what you get for $1. Here it's about $1 for 10 miles. I've seen the lowest is about $1 for 7 miles. And not counting this one in Holland, everywhere else we've been sort of east of the Mississippi. The max has been about $1 for 11 miles. Sorry, I did the wrong way. Cheapest was $1 for 11 miles. Most expensive $1 for 7 miles. So our experience depends on the charger power, but kind of in general, I've got all kinds of data, being kind of a data geek. So minimum, we get about 101 miles an hour, max about 501. Our average is about 280. And then there's this preconditioning, and we'll talk about preconditioning. Preconditioning basically in the Tesla world and some of the other cars have this feature, but not all of them do. And basically what it is it heats up the battery to the optimum temperature so that the inrush of electrons can be as fast as possible. And so I have statistics about what we've experienced when we're preconditioning versus not. In fact, I have a graph coming up. So with preconditioning, the average is about 357 miles with preconditioning. So my recommendation is joining networks, and we'll talk about networks to join and what not to join and so forth. And then we'll talk about plug and charge and what the difference is, what that's all about coming up. So here's talking about the preconditioning. And this data is about a year old. And trying to recreate this data is not easy. So one is, if you look at the two graphs, I'm adding 171 miles to the battery. And twice. And getting that number on two different occasions with different technology, that's not easy. So that's why I haven't updated this graph, because I don't want to have to do this again. So in one case, I added 41.15 kilowatts. In the other case, I added 41.16. I tried to make them the same, but it wasn't easy. So in the upper case, the battery is preconditioned. In the lower case, it's not preconditioned. In other words, the upper case, it was heated up to the optimal temperature and ready to go. And I had a significant enough, I had a good level 3 charger. So in the upper case, the preconditioned battery, I gained 171 miles in 26 minutes. In the non-preconditioned case, I added 171 miles in 63 minutes. So in the Tesla world, preconditioning makes a dramatic difference in the performance. Susie?
One of the things that's nice about the Tesla is that if you have a charging station in your navigation system, it automatically preconditions the battery as you approach it.
You bet. You're going to see that in the video coming up. So here are the charging networks. these are the biggies, I'll say. So the top one is ChargePoint. Let's talk about the graph. ChargePoint is by far the largest charging network out there. They have 38,000 charging locations. But if you look closely, the second column says how many are level 2. And so they have 35,000 are level 2. And if you talk about the number of ports, if you saw that connector, they generally have 2 cables. And so the number of ports is roughly twice, not quite, but roughly twice. Number of level 3 chargers, they have 3,166. And they typically don't have multiple ports on their level 3 chargers. So the last column, when you're concerned about contention and when you're concerned about reliability, that last column matters a lot. So basically what that last column is telling you, if you find a charge point level 3 location, you got one shot at it. If somebody's parking there or the charger is out, you're out of luck. So then Tesla, they have 7,000 locations, of which about 2,500 are level 3s. They have some destination chargers, quite a few, but where you really are focused on is level 3. Notice they have an average of 11.1 connections at their locations. Typically what we've seen is we see about 8 the typical configuration is 8. In fact, they have a modular deal for $200,000. It's the electronics and the 4 station chargers on a piece of cement. Now bring it in on a flatbed and drop 2 of them in, $400,000, and that gets you 8 ports. I think the most Susie and I have seen is 16, but you can go out to California and there's locations that have 50 chargers. Because there's so many chargers out there. So anyhow, it's important to note that 11.1 and in general, if you look at charging experience, and it's changing because a lot of people are having to respond. Historically, Tesla chargers have about a 95% success rate when you plug in. The other folks across the general numbers are about 60 to 70%. So that number of ports per location matters. So Blink is another great network, and you can see their mix of level 2 and level 3 chargers. Most of them, again, you see because the number of locations are level 2. Flow, I've never encountered a Flow network, but they have a pretty good penetration. Volta was bought up by Shell Recharge, and that just happened. And so the data that I pulled earlier this summer, they were still broken out as 2 different companies, but you can see how they mesh. I'm going to come back to EV Connect. Then Electrify America, they're a really good program, but they're now on their 3rd generation of hardware out there because their 1st generation had reliability issues. And if you don't know who they are, they started by Volkswagen. And if you remember the Dieselgate drama that they had, that's their answer to paying back in the US through agreements and whatever to build a network to support EV charging. And they are going to grow dramatically. We've used their equipment. It's good. The generation 1, not so much. You'll see some pictures of the generation 2 and 3. EVgo is another one that I've used a lot, and they're excellent. Rivian, they're now, we have some pictures. I haven't seen their network before, but they have good level 3 chargers and level 2, and a lot in Michigan because they're in Illinois. And then Reddy, I only included them because they're Detroit based, and if you go up north, you'll see down in Saugatuck because there's a guy down there that's putting them in. And so we'll talk more about those guys. EV Connect. So EV Connect, they put EV Connect, Barbara Ford put in an EV Connect system. And they took forever to make it live or take it live and so forth. So in my usual deal, I said, well, let's go try it. Well, I tried it. And the highest rate that we've ever encountered east of the Mississippi, because we haven't taken our electric cars west. So we've been down to Florida, we've been to the East Coast and so forth. About the highest I've ever been charged is about 54 cents for a kilowatt hour. And typically Teslas, you typically see more in the low 30s, or sorry, high 30s, low 40s. That charger charges $1.05 a kilowatt hour. It's twice the amount. So I'll show you where it is on the map. I don't recommend, I mean, if you're desperate, I'd go there, but you're going to pay. And I don't, who's setting that? I don't know if that's a Barber Ford issue, because most of these networks, they'll offer the equipment. Like if you want to, we have a condo down in Florida, we're talking to some companies to put them in, you set the rate. They reimburse you for the electrons and the charging, and then are you trying to recover your costs or not, and whatever. So, Gary?
As one of those funky non-Tesla guys, we use strictly CCS, haven't gotten my converter yet. My experience in driving, again, East Coast, east of the Mississippi, ChargePoint is my favorite because I've hardly ever had a problem with them.
Yeah.
And quite often there will be, up to 4 ChargePoint kiosks next to each other. So the fact that each one has only one cord doesn't bother me.
Yep.
Also, their payment method through their app is just super easy.
Yes.
Electrify America is number 2.
Yeah, I would agree.
EVgo is number 3, but if I can find either a ChargePoint or an EA, I've had pretty good luck, except with Generation 1 EA, which is awful.
Yeah. Yes. Yep. And
Dave, I was just going to mention, I think this is correct. The Ford DC charger that they have over at the Ford lot is the only non-Tesla level 3 charger in town.
oh, yes, that's
Which
true.
is shameful because there's quite a few of them, 3. Well, they don't have Tesla down in Saugatuck Douglas, but they have 3 DC charging stations down there.
Yep.
And Spring Lake has one.
Yep.
And Holland has just one lonely one. And there's a lot of EVs in this town.
Oh,
we've
there's a lot.
noticed.
Yep. Good point. So the retail stores are trying to get into the business too. And some are much more aggressive and smarter about than others. So I used to live out west, so I thought, well, how are the big guys out west doing? Not so good. So if you look, the chart shows you the number of locations that the company has, the number of installed locations that have a charger of some sort, and I calculated a percentage. Circle K, for example, they have 52 live and there are 41 under construction. 7-Eleven doesn't say anything about what's under construction. Wawa on the East Coast, they're great. Been to their places in a number of occasions. So they have a large number of units and they're up to 17% and aggressively rolling out to other sites. Sheetz is another convenience chain on the East Coast. They have 90 installed. They're up of about 14% and aggressively trying to expand. Pilot travel centers have announced that they're partnering with EVgo and GM. They are currently at 17 installed. Travel Centers of America, they've announced a partnership with Electrify America for 200 locations. Sorry, yeah, Electrify America, but nothing to date. Now, Buc-ee's, if you haven't ever been to a Buc-ee's, you got to go to a Buc-ee's. So Buc-ee's, they're in south part of the country. They started in Texas, but you can find them in Georgia and Florida. Buc-ee's is a really unique animal. No trucks allowed. And you go to them and they have about 100 gas pumps. And the convenience store is the size of a grocery store. And it's a mob scene. And so they've been there. It's an experience. You may only have to go there once, but if you haven't had the opportunity, you need to go. What's that? Yeah, great barbecue sandwich. Absolutely. They have great food and they're just amazing. And they've made a huge commitment to EVs. And so every one of their locations typically has a Tesla. We've seen ChargePoint. We've seen ChargePoint chargers rebranded as Mercedes. And so I didn't have the opportunity to research that. We were trying to drive home. But I thought that was interesting. I recognize the technology in use, but it was branded differently. Actually, I think we saw one at a casino up in Mackinac City that was a charge point. And by the way, Gary's analysis is right on. Those are the top three. And then Walmart has announced a partnership with Electrify America. They're up to 280 locations. They have 4,606 super centers. Not talking about Sam's or any of that stuff, just the super centers. They have 280 installed, and their intention is that, and I haven't tried this, not a big Walmart shopper, but if you have their app and you go to the Electrify America charger, you get a lower rate. And so I don't know what the rates are. Again, I don't know the details, but they are aggressively going after it. Myers, they have about 260 locations, and they're up to 52 at the moment, or about 20%. And and most of them are, they're a Tesla or Electrify America or ChargePoint. We've seen all three of those. Typically it's Tesla and somebody else. And what we do know about that relationship, I've tried, but because I worked with the competitor, I don't think they're real interested in talking to me. They offer the real estate for free to the charging company. So they can come in and install, and away they go. So pretty cool. So that's kind of the state of the retail side of things. So I hired this expert here to come and present. I'm going to have to play with the audio, so please be patient. Yeah, he was very expensive. I have to say. Yeah. And you're going to get to see him again next week, but I had to do this because
Myers, Holland, Michigan, Street, and I'm going to demonstrate supercharging. Say Tesla supercharger.
oh, let's start this again.
So first of all,
Sorry for the.
okay, we're at a Tesla supercharger, Myers, Holland, Michigan, 16th Street, and I'm going to demonstrate supercharging. It's a Tesla supercharger in a Tesla car. So first of all, I simply take the cable, push the button. Sometimes it works, sometimes it doesn't. So I'll touch it and open. All I do is plug in. It will electronically recognize this as my car and send the bill for this electricity that I'm loading right now, send the bill to my credit card. I don't have to do anything except plug in. If I walk away and leave the car charging, it will warn me when I'm close to full capacity, because if I left my car here indefinitely, I'd get penalized for taking up a spot and no longer charging. So, but it would warn me on my phone, wherever I was, in the restaurant eating or whatever, that I need to get back to my car within 10 minutes, or I'll start paying a penalty. But that's only true if half or more of the stations are being used. Otherwise, there's no penalty until more cars show up. Okay, I'm going to unplug it now. We didn't really need electricity. We just came here to demonstrate. I'm unplugging it, trying to unplug it. There it goes. Back to the stand, and we're done.
So the rest of the videos are with some lackey that showed up. So anyhow, okay. So the point there was simplicity. You just plug in and away you go. Didn't have to interface with any apps or anything else. What I'm going to show you now is a trip that Susie and I took up north. And in the navigation system, and where I'm going to show more extensive demo of the navigation system a little bit, but how you navigate and sort of have to think about where you are and what you're doing, and a little bit of a demonstration of preconditioning. So I'm sure there'll be a lot more uhs and so forth here, because I'm not a professional like Bill, but.
So we're getting ready to travel to Petoskey, Michigan. for a week's vacation. I'm sitting in our Tesla X and I'm showing you the dashboard screen. And what I want you to notice is on the lower left-hand quarter, our battery has a 338 mile charge right now. We charged it 100% last night. So we're ready to go for our trip.
In preparation for our trip, I've gone into the Tesla navigation and I'm going to select the Courtyard Petoskey, the Courtyard Marriott at Petoskey in Victory Square. So based on that, it does the calculations based on the battery capacity. And it determines that the best way to go is to travel up 131 directly to Petoskey. And it indicates that once we arrive there, we'll have a 29% battery capacity when we arrive. Now, Petoskey, there are no Tesla superchargers there. So we want to take a more conservative strategy. So I'm going to change the navigation point. Because we'd like to have a larger, more energy in the battery once we get to Petoskey, I'm asking that we go to the Tesla supercharger in Cadillac and charge before we head up to Petoskey, before we go to the final distance at Petoskey. So it's now doing the calculation, says we go up 131. And what's important to notice here is that when we get to Petoskey, we'll have a That should say
53%
Cadillac. capacity or charge left on our battery. So we'll pick this up once we get to Cadillac, so you can see how the charging process works. So now we're getting close to Cadillac. One of the things to emphasize here is what Tom said. Because I navigated to a Tesla supercharger, it knows that I'm going to charge there, assumes, I should say knows, it assumes that I'm going to charge there. And therefore, when the time is right, based on the temperature, the speed, the temperature of the battery, the outside temperature, it says, okay, because I want to optimize things, I'm going to automatically turn on preconditioning. I don't have anything to do with it. The car makes those decisions by itself. It's in the video. And you can see if you look at the display, it now says preconditioning for battery for fast charging. We're 24 minutes out, and we're about 24 miles. And you can see it's now saying that we'll have 51% battery capacity. And if also you look over here, you'll see that it's 76 degrees out. So we're now warming up the battery to be able to accept the most amount of energy in the quickest fashion. So just wanted to note that that's happening, and we'll talk about it once we get to the charging location. Okay, we've now arrived in Cadillac at the supercharger station. You can see there's a whole bunch of superchargers here. So for us to connect, we reach and grab the cable and press the door, which opens, and plug in the cable, and that's it. So now you can see, if I can get the camera focused properly, you can see, looking at the dashboard, that we're currently charging at 142 kilowatts. The charge rate is about 474 miles per hour. It's already added 3 miles. And if you look over, that's all on the right-hand side. If you look at the left-hand side, you'll see at the bottom, 175 miles. So it's now added 4, so that, or 177 miles. So we came in at about 173 miles, and you can see that on the left-hand side is telling you that we have 15 minutes to an 80% charge. So once we had it set at 100% when we left, and the rest of the time in the trip was set it at 80%, because that gets us the fastest charging rate and is reasonable in terms of capacity. So we'll connect in later. Oh, maybe that's the end, sorry. It is. So that's that step. I broke these up for a reason.
So we're getting ready to travel to Petoskey, Michigan.
No, oh, yeah, sorry. Okay. So, so we started charging. Sue and I went into Myers, did a little shopping, got some drinks, snacks, whatever. On our app, if you look on the left-hand side of the screen, you see two screenshots of our Tesla app. So the first screenshot on the left shows that we're up to 240 miles up in the upper left-hand corner in green that we've added. It says there's 10 minutes remaining to get to the charge limit. Down below, under the car, you can see we're currently now down to 95 kilowatts. And it's at a rate now of about 328 miles per hour. And then we've added 67 miles. The next panel, the sort of the middle panel, if you will, shows that we're at 261 miles on the charge. There's 5 minutes remaining. And if you look down under the car, we're at 77 kilowatts. So it's slowed down some more. It's down now to 266 miles per hour, and we've added 88 miles. So with the one, when you're off away from your car, you can always see what's going on. And it tells you messages, gives you messages and says, hey, you're almost done, etc. I didn't show that as an example. And so then here's the ending video. So our charging is complete. So my camera operator is not available. So I just press the button and release the cable. Put the cable back in the unit. The door closes and the charging is complete. So now, so that's an example, 2 examples of what it's like to charge a Tesla with a Tesla network. So now let's see what it's like to charge with Blink. This is a little rougher. I apologize. I stumble around a bit and so forth, but it just gives you a little bit of a concept of what using and this is level 2. This is not level 3, but it really doesn't matter conceptually what I'm trying to show you. So we'll pick it up here.
So today we're going to do a demonstration of a level 2 charge, a non-Tesla charge. We're going to use Blink. We're up in Petoskey. You notice looking at my screen, there's 174 miles left. Now, normally that would be okay, but because we're up in northern Michigan and we tend to take long trips to different cities, we want to get a full charge. We're going to be in downtown Petoskey today. So there's a level 2 charger in our parking lot. So we're going to use that. So next we'll show the connections. So here we are in a Petoskey parking lot. You can see our Model X, the trunk is open because I need to get the adapter. And as you look, you'll see there are 2 Blink level 2 chargers here that we can use. So first I'm going to get the adapter for Tesla from a Blink connector. We need to interact with the Blink app. So I select the app. I do a location and it sees that we're in Petoskey. And I zoom in to find the connector. There's a few different Blink chargers here in town. I'm at a parking lot. This is City of Petoskey parking lot. It's a level 2 connector. And so we're now, but you can see both of them are available. They're 21.6 kilowatts, which is very good.
It's actually not true.
And so we're going to select one of these connectors to charge. We have our charging kit of the various adapters and so forth for our Tesla. I pulled out the adapter for a 1772 connector to the Tesla connector. This is the Tesla and the 1772. I pulled the Blink connector out and I put the adapter on and open the Tesla charging door. I can get it to wake up and insert the connector. If you look, you can see it's blue. In order to get it to green, I have to turn on the Blink connector. So I go back to the Blink app. Now we're done with the charging. You notice on the lower left that we now have 270 miles. Outside temperature is 69 degrees.
You can see on the right, the charge rate is 0 miles per hour, and we gained 97 miles during this charging episode. So I'm now going to get out of the car, show you the removal of the blink connector, and then we'll go and look at the blink app to see its version of the results. Two cars here in the two EV parking lots. Notice it's a Rivian. Check out the license plate R1T, which is kind of cute. So we go in and we look at the chargers. Now, the key here is because we have the adapter to pull this out of the Tesla, I have to unlock the port. So I'm going to stop the video a minute. So I've unlocked the port. So you can see I still have the adapter on the connector. The door closes. I pull the adapter off, put the connector back in, and notice the blink says that it cost me $11.50. And the last thing I'll do is put my connector away and we're done. Sure.
To unlock the adapter, did you use the unlock the connector on your Tesla app?
Correct.
Oh, okay.
Yeah.
So there wasn't something on the unit itself.
No.
You did it in from the app.
Yeah, that's one of the catches. When you put on that 1772 adapter, if you use the button on the Tesla, on the blink thing, it releases the connector and you stuck with the connector in the port. The door tries to close and I can't. And so then you have to go into the car, unlock anyhow. So as opposed to saying stop charge and all that business, I just say unlock. I tell Tesla through the app, unlock the connector, and then I pull out the whole unit and pull it apart.
Yeah. Okay.
So it's sort of a practice that when you use enough brand X connectors, that's just a habit you get into. All right. So
Dave, we have another question here.
oh, sorry.
Tell us what the optimal temperature is, a preconditioned battery, how warm, is it just warmth or is it humidity or, and that's question one. And then question two is if you're going to a non-Tesla supercharger, can you manually precondition your battery?
Great questions. Okay, first off, I don't know the temperature. I just know it's warmer because I know that when we're in warm climates, that the test, I've seen the pre-conditioning happen within 5 minutes. If I was down in Florida, for example, and it's really warm out. And so, but I don't know the specific temperature. So that's the answer to the first question. Second question is, when you go to a and they're changing, like they've recently changed the interface so you have easier control over preconditioning. What we've historically done is we find a nearby Tesla charger and we go our own way. And so it still thinks that it's charging, but that's not a perfect solution, obviously, but there's now controls but I haven't used those yet. So I don't know the perfect answer. So, okay.
So Dave, you're saying that we can actually trigger the preconditioning on our own without telling it going to a Tesla charger.
Yes.
So
yes.
that would be the key for the Tesla people.
I believe it's either way. I haven't looked at it closely, but yeah. Yep. So and I got to be careful because I'm running out of time. I got a couple more videos here. Talking about the Tesla, so I call it the Tesla experience of that with my professional over here, how easy it was to connect up and so forth. And so there's efforts underway, standardization efforts underway to make the third-party chargers work the same way. So if you have accounts with the third-party chargers, I'll show you a little bit about that. There's two technologies that are out there. One is auto charge, and that is supported by CCS connectors. It's a more rudimentary version, but there's the one that's really presuming it's going to be the dominant one is plug and charge. It's a different, and it's based on an ISO standard It's much more secure. It's much more sophisticated for the charging and the automobile manufacturers to implement. Plug and charge, the network support is in Electrify America, EVgo, and Blink so far, based on the data that I have, or that I was able to get. And then automakers, selected models of various manufacturers, of those 5 manufacturers, are working on plug and charge. Tesla as yet is, because of its legacy, is a third method. And so I believe over time, all this is going to consolidate down to one. What that's going to be, I don't know, but just to let you know, the rudimentary stuff you saw with Blink, they're working to try and make it all simple, because they should be able to all exchange the VIN number, and recognize who they are. And because I have, well, you'll see in a minute, I've registered my credit card and so forth to all these networks, so that it makes the ease of use better, because sometimes the card readers don't work well and so forth. So I found the apps are the better way to go, but they have more work to do to make it simpler. So these are all level 3 chargers. Electrify America on the left, that's Gen 2 up at the top and Generation 3 at the bottom. EVgo, the one up at the top is their sorry, I got them reversed. Second generation. The one at the bottom is their, I assume their first generation, the only 2 I've seen. Charge point, you see that at the top. And again, you'll see that it's very characteristic design, but sometimes you'll see a different brand on it. Blink, that's a level 3 charger for Blink. On the upper right, those are Rivian level 3 chargers. That's up on Mackinac City. On the lower right, the second one in is a sort of a brand X. So if somebody wanted to put in a level 3 charger that was not associated with a particular network, that's one that I'm aware of. And then you see the Tesla installation. So lots of different brands, lots of different configurations. Some folks ask me, I actually need to update this. The average fleet, if you want to compare gas versus electricity, the average fleet, the US average for the fleet, and this is probably getting a little dated, is 25, because this is from last year. I didn't update this one, was 25 miles per gallon. And so if you talk about adding 200 miles of capacity to a car, if you had $3 gas, that's $24. If you have $4 gas, that's $32. My old Camry hybrid, back when it got 34 miles a gallon, I'd spend for $3 a gallon, or $3 for 200 miles. It cost me about a little less than $18. At $4 a gallon, around 24. The Tesla Y, if you're in BPW territory, that cost is $348. If you're in consumers energy catalog territory, that same cost is $6.40. If you're at a level 3 charger, it's about $20. So you can see the level 3 is pretty close to what gas is. In terms of time, that's the bigger question. So on the level 2, you're typically charging at night, and so that might be 4 hours and 23 minutes. At level 3 charger, 200 miles might take you 30 minutes. So what do you spend time at a gas station? 10 minutes, is it 15 minutes, whatever. What we find at our age, we go to a convenience store, use the restroom, get a drink, and the car is charged typically by the time we get out. At most, maybe we wait for 5 minutes. So it's a minimal thing. So tools, this is my last section here. It's very important for you to understand what kind of tools does your vehicle have. And then there's plug share. I'll talk about that in a minute. And then for trip planning, that's about finding chargers. And plug share is, in my opinion, is the gold standard. Trip planning, your vehicle may have tools. You've seen some of the Tesla tools. Again, plug share has trip planning, a better route planner, which we're going to talk about in a minute. And Google will tell you they have tools. Don't buy it. I thought, oh boy, there's a lot of progress. And I went out and checked it out, and like finding chargers, because they want to have ratings and do all this stuff. plug share is like 10 times better. They're at very early stages. Now, 2 years from now might be a whole different matter, but ignore it for now. So this is I have on my phone, my EV screen. And so if you look at the top row there, there's the ChargePoint app, the Electrify America app, the Blink app, and PlugShare. Then the second row is EV Go, red E, because we spend time in Florida. Florida Light and Power has their own network, very nice level 3 chargers. And then the second row on the right, the icon is for a better route planner. Then you can see the others don't matter as much. That X way on the second row, that will go away on October 11th because that company is getting out of the business. There's other tools, but in my opinion, those other tools don't compare to a better route planner and PlugShare. So, yes. Say it again. Oh, and a better route planner. You're going to see, I'm going to show it. And I know we're running out of time. I hope this is okay with everybody.
Better Route Planner is excellent. I use that. If you are an Apple car share user,
yeah,
which Tesla is not, once you get a low range warning from your car, Apple CarPlay will automatically start displaying on its maps all the chargers from any network that are, within the scope of your map, and you can expand it or close it. So that's handy also.
Very cool. And Tesla does a similar thing, although we haven't experienced it because we're too conservative and we don't let it get that low. Okay, so, and I got to keep going. Hopefully this is okay with everybody. PlugShare, there's 2 screens here of the Holland, and Saugatuck area. On the left-hand side is zoomed out, and what you see is those icons tell you a lot. The orange icons are level 3 chargers. The green icons are level 2 chargers. And you'll also notice in the center at 196 and 40, you'll see an orange with a wrench in it. That means that there's going to be a level 3 charger, but it's not up and running yet. So it's under construction. The Tesla, my wife was talking about there's 3 level 3 chargers down in the Saugatuck Douglas area. And then you can see up in Holland, there's only 2 and one's real expensive. And then you can see you can zoom in and zoom out. I wanted to try and give a bigger picture, and then you can zoom in. And then once you do, if you touch one of those icons, the left-hand side is the Holland State Park Rivian chargers, and you can see the panel there gives you a lot of information about them, and you can scroll down and so forth. And people, you can sign in and indicate that you've been there and leave a note or whatever. I left a fun note on that EV Connect one. Then there's Douglas Berry Field. Oh, so I mentioned Holland State Park, those are free. And then if you like to go down to Douglas, we like some of the restaurants there. Berry Field is a baseball field right in town. And on the east end of town, there's a little building of restrooms for the park, public restrooms. On the back side is a ChargePoint charger that's free. And so we go down and we have dinner at EPC or Wild Dog or whatever, and plug in on our way down. And when we go home, we've charged up we live on the north side, so we're net miles we're ahead. And it seems to cut off at 48 miles in our car. I know there's we heard recently that there might be some debate about them turning on charging or cost, but it's really nice. And what we did in Holland State Park, if we haven't gotten our steps in, we'll drive out to Holland State Park, plug into the free chargers there, and do our 30 minutes of exercise and come in and head home. So then the right-hand panel that shows the 2, I touched the Meyer location, so you can see the information it provides about the Meyers. So this is a little video of Route Planner, and I'll just so Better Route Planner over on the right, the panel, you indicate parameters. So it's Tesla Model Y, you've been the state of charge, how much charging you, what's the max, your assumptions, because it's not connected to the car. Hold on a second. Because this isn't connected to the car, you have to tell it everything. So what you saw in the demos for Tesla is it knew the state of the car, it knew through navigation where you want to go. In this particular case, I had to tell it I'm a Tesla Y connector. I said that for this trip, I'm going to start out at 100% state of charge. And then the types of chargers that I support, you can see I've selected the Tesla supercharger, the Tesla CCS. In other words, I have an adapter or a CCS. So I can handle any of those three types of chargers. So, and I can say what networks I prefer. I can say, okay, what's the minimum battery that I want to get down to? Conservative said 20%. And so again, parameters on what's your assumption about battery, you're charging. So what is your maximum speed? So it's going to do its modeling. It's saying 75 miles an hour. What vehicle? The battery, the parameters about how you expect your vehicle to perform as it relates to the electronics, road conditions, to use real-time weather or seasonal weather. So then I come in and I say, okay, I put in my home address somewhere in there. And then in this particular case, I'm going to go to Philadelphia and the Franklin Institute in Philadelphia. So it says, okay, here's the start point and the end point. And it's thinking and doing its calculations now. And when it gets done, it says, okay, here's the route to drive. Your first stop should be in Dundee at a charge point. The next is an Ohio Turnpike, the toll plaza there. And it's telling you the timing. It's telling you the what level of charge you're going to be when you enter. And how long it's estimated it'll take, and steps you all the way through that. And then it shows you on the map the different and there's alternate routes and so forth. And oh well, sorry. Oh, I'm starting it all over. I apologize.
It's all right. When it's telling you those locations, is it saying that there's an open station for you at that point in time too?
It doesn't, it depends on the network as to whether they're connected to know what capacity there is. It's static documentation versus dynamic. So typically in this particular case, it's static information. I don't know if you've had different experience, Gary. Okay. The Tesla network and some of the networks will give you dynamic information. This one does not.
Dave, the feature that I think is outstanding for better route planner is that, it gives you Dave's settings and Susan's settings. You can say, I want to charge frequently.
Yes.
Or you can say, I'll go the distance and charge this every once in a while, or points in between.
Yes.
And that's really handy if you've got uncertainty about the reliability of chargers in certain parts of the country. You can just say, I'm going to charge every chance I get, and it will do that.
Yep. Yep. So this, go ahead. With Tesla, you do. It tells you how many chargers are available. Oh, sorry.
I'm sorry. The question was, do you ever know how many cars are ahead of you at a given station? And you said, yes.
Yes.
As a Tesla.
In the case of Tesla, and they also know how many are converging. So it's, and these are all recent enhancements. So it knows that, right now there's this many and there's this many coming. And so here, and it even shows you, well, you'll see it in a minute. It gives you a histogram of how busy, time of day, how busy those charger locations are. Okay.
Yeah, I found that it told me I should get there before 11 o'clock.
Yeah.
And I did. It was 10:30. At 11 o'clock, when we got there at 10:30, there was no one.
Yeah.
At 16 stations, At 11 o'clock, there were 5, and then it went up from there.
It does
But
work.
Dave, that one time when we were going to a charger close to us down in Florida, it said, you might want to go to this one and down 5
Oh,
miles
yes.
further down the road
Yes.
because it knew a lot were coming or there, it was pretty
Yeah.
full.
Sue likes to call this particular location the beehive because there's 8 chargers and there aren't many. We're out by the ocean and there aren't many nearby. And there's just cars coming in and there's a Wawa right there. And we've come there when all stalls were busy and there were people driving around waiting. So anyhow, we're told that there's a new one coming in. All right. So now this is the same thing with our Tesla on our Y. So I'm going to go in and tell it I want to go to Philadelphia to the Franklin Institute. And when I did the better route planner, I said, I don't want to come in less than 20%. So I did a very conservative, and I can't remember all the other parameters. This, you'll see, we have a lot less charging locations because first of all, it has more information, but it's not as conservative as how I had set a better route planner. So it's doing the calculation to figure out how to get to Philadelphia. And so there you can see where the other one had 6 charging locations, this has 4. So it says, here's the best route. And it says the first place you want to charge is at Ohio Turnpike, the Tiffin River Service Plaza. You can see there's 8 stalls available, 250 kilowatts, so good charger. And then busy times, you can see the histograph there and see that it's 39 cents per kilowatt hour. And I'm showing the time and will come in at 33% in the on the charge. Oh, and then there's icons that show you what services are available there at the bottom. So then we go to the next one. And this one is the new Springfield, Ohio Hills Service Plaza, 8 stalls, 250 watt max, 39 cents per kilowatt hour. Gives you mileage, again, says the little icons there for restrooms, food, etc. And then Somerset, again, 8 stalls, 42 cents per kilowatt hour in this particular case. Oh, and there's an idle fee. Bill talked about the idle fee. There's $1 per minute if the chargers are booked and you're hanging around not charging. And then finally, Denver, PA, again, 8 stalls, 250 watt max. This one is 40 cents per kilowatt hour, and it has an idle charge as well. Oh, and then
I'm curious about the lowest that it got.
well, he holds the record. He's come home with only 5 miles on the battery. I suspect he was driving locally and he knew what was going on and so forth. Maybe not, I don't know. I don't remember on these particular trips, but Mama gets pretty nervous if it's under 10. Well, she gets nervous under 20%, but I get nervous. I don't like to go below 10%. Is kind of my deal.
Yeah, I don't go below 20%. And sometimes it would say, we'll come in on a 23, but you only need to charge 15 minutes and you can go and keep on and not go to a
yes.
full 80% charge. Never let that happen. I would always stay longer. And frankly, we couldn't get everything done in time to make it back in the short amount of time. We needed that full time to get the charging and get all our stuff done.
So last slide here. So if you buy one of these cars, these are questions I ask, and others can make comments, but the traditional automotive dealers, it's surprising, it's shocking what they don't know. But what you're going to want to ask is, what's the range of the vehicle? In other words, what's the battery capacity in miles? What connectors are supported? Are adapters available? Does it support level 3 charging? Most of them do. Is the charging interface 400 or 800 volts? Again, that will become a more common potential in the future. Does it support preconditioning? And some of them come with one of the network contracts. Friends of ours bought a Kia and it came with 1,000 free miles with Electrify America. So different companies have different offers. And then what kind of route planning software it does. So you can see with these different alternatives, having that integrated in the vehicle is a really nice feature, and it's something you want to look for. So I'm sorry I ran so long. Hopefully this was useful. If you have questions, happy to entertain additional questions. Yes, sir, Louis.
Perhaps you have some thoughts on this, and the other owners of EVs might have thoughts as well. Fossil fuels are going to be around for some time in this country.
Absolutely.
There are some cities around the world who have declared that by a certain year, they will no longer allow internal combustion engines in their cities. Amsterdam is one of those.
Yep.
In fact, they've already started to restrict traffic. It's become pedestrian or public transit only. And then you introduced us today to the fact that there are some retailers of gasoline, such as Sheetz in Pennsylvania and elsewhere, who are now introducing chargers for their other customers. So how is the entire industry going to change in the next 10 to 20 years in terms of labor requirements? We are going to eventually not need petroleum refinery. That's sometime in the future, of course. But how will this change our labor habits, employment, use of public transit, because they are going to presumably become electric. Some of them are natural gas now. Any thoughts about all this?
Yeah. I cannot answer all the aspects of your question, but I have some comments. One is, you hear predictions from some automotive makers of how fast they're going to transition. My contention is the transitions, unless a country does sort of an edict and so forth, and Norway and some of the Nordic countries have been very aggressive and very successful. In our country, the petroleum industry is a big deal, big lobbyist and so forth. And our political nature, as frustrating as it is causing a lot of fighting about electric vehicles. My comment is it's going to take a long time. And one of the reasons I say that is, so we've been doing this for 3 years and some others have done it longer. If you talk to others that are they're curious, but they don't really know anything, as you describe it to them, first of all, they have no clue. And then second of all, and then they have a lot of misinformation because people that are anti are saying, oh, there's range anxiety and this and that and so forth. And what you realize, it's not a big deal. So there's all these counter forces in our country. Refining and the need for oil-based products, that's going to long exceed electric vehicles. There's so many other things that fossil fuels are used for, not necessarily coal, but oil, certainly. So it's not going away. But just our experience, again, my basic experience with just talking to different people, after you talk to them, they go, well, that's pretty cool. But they have all this information that's publicized for whatever reason by whatever faction of whatever that scares them or makes them less confident of how what the environment's actually like for electric vehicles. So I think it's going to be a long time. And I would make one other comment is that we recently took a trip out east and we saw electric buses. And it was quite humorous. I even have pictures. I won't bore you, but we were on an island, and we went to a visitor center to use the restrooms. And I saw electrical cabinets because of my geeky nature. I go, well, that looks like charging equipment, and so forth. And I go, well, this is it's a visitor center. Well, all of a sudden I go out and I look in the street, and there's metal pads, 2 of them. And a bus comes up and drops the people off and releases and goes down, and they're charging. And so they had 2 buses, or at least 2 that we saw. There's 2 of these stations. And so it's happening in lots of different ways, but I think it's going to be a very long time, would be my general comment to that. Gary, you might have some other.
I was just going to add to that also, BP, when we talked to Sean,
Oh, yes.
our son-in-law's brother, they're putting a huge emphasis on EV or electric charging.
Yes.
With their, and
So is Shell, like
Yeah,
one of those,
Shell.
apps that it was is Shell Recharge.
right.
And so the convenience stores are starting to get it, but
Yeah.
I think it's going to be a slow crawl.
Anyway, but they see it coming. You know,
Yes.
they're thinking about it.
And the other comment I'll make is being in several others in here are EV owners. Once you make the transition, I would never consider getting a gas car. They're so much easier. They're fun to drive. The pickup's amazing. It's so convenient, charging at home. It's a wonderful experience.
Two famous sayings, cherchez l'argent, follow the money. As dealers and manufacturers figure out how to make money on electric cars, all of a sudden there's going to be a sea change. And you know, people who are just out shopping for a car are going to find that the manufacturers are pushing EVs and the dealers are happy to sell them and collect whatever profits they figured out. You know, the other famous saying is, we always overestimate the impact of a technology change in the short term,
Yes.
and we underestimate it in the long term. As electric vehicles become more and more the norm, there will be side effects and long-term effects that we can't dream of right now, but they'll be real and they will be transformative.
Yep.
Any other questions? Oh, Louis.
Back to the batteries.
Yes.
Range anxiety is one thing. Another
Yes.
one is usage in a cold climate.
Mhm.
Occasionally it gets cold here.
It does.
And my understanding is that in Norway, or no, I think it's in Finland, that they have a very high sales rate of EVs.
Oh, yeah.
So how do they deal with winter temperatures there? Because it gets colder there more often than it does here.
Yep.
Batteries tend to drain their energy in cold weather. How do they handle that?
So, and I don't know the details. I know my wife knows some of the statistics better than I do, but based on personal experience, I see about a 20%, we've experienced is about a 20% degradation. But if it's in the garage, and you know, keep it plugged during the winter time, we keep it plugged in all the time. It's yes, you have to make the adjustment, but with the range of the cars and local driving, it's just not an issue. It's real, but once you get accustomed to these vehicles, and I don't know if you have different opinion, either one of you or anybody, but it's just something you adjust for. But it doesn't, I mean, the cars are functional and, you know, the news always wants, you know, to create excitement and so forth. So when there was the big cold spell in Chicago, they all talked about, oh, they went to the chargers and so forth. Well, they probably didn't precondition, probably didn't understand it. Our classic example, we were down in Florida. We went to one of my, let's go experiment with some EV Go chargers. So we go to EV Go and it's at a big outdoor mall thing. And there was a guy there with a Tesla S backed in, plugged in, and he wasn't getting any charge. So we were doing our business and so forth. And he said, is it working for you? Oh yeah. What's the problem? And so we went over and talked, and he had rented a car and nobody had taught him how things work. So he thought he could go to an EV Go and just plug in and go. He didn't have the app. He didn't understand. And so, and this one had Tesla and NACS connectors to it. So the Beehive, this real busy Tesla charger thing was, I don't know, a couple miles away. And so we went in to his navigation and explained to him what was going on. And when the navigation said, just drive over there and plug in. And he goes, thank you so much. He said, he had no clue. We had another time up north in Michigan, somebody had loaned an individual a car. He was down to 65 miles. And he didn't have the whoever loaned him the car hadn't given him the adapter, and he couldn't charge because it was a 1772 and he didn't have the adapter. And so we offered, and he said, well, I have to go. I said, okay. Again, navigation, Mackinac City, go up there. You got enough mileage and so forth, and charge it. Oh, I mean, people don't understand. And so whether it's cold, I mean, all the different things, whether it's cold weather or whatever, once you learn, it's not a problem. I mean, it's a different range. And some people have, we have cars that have 300-mile ranges. Some cars have a lot less than that, and they get by fine.
I wanted to add a couple of things here because I'm his research assistant of this data. And this is not pushing Tesla at all here on it, but the number one car sold globally is the Tesla Y. So I think that's some encouragement that you're seeing electric cars are being accepted globally. In the United States, it's number two, just slightly behind the Toyota Camry and ahead of the Ford F-150 for the Tesla Y. So just want to let you know, there is movement in the EVs here that they are being adopted globally, especially in US slowly.
Mm-hmm. We've probably taken way more time than you wanted. And any other questions? Sure.
What about the wear on your tires?
Oh,
I mean, because the car weighs twice as much as an average car. So do they sell you different tires?
They are specialized tires. But the general, what I've heard, and this guy's had a lot more experience than I assume they run around 40,000 miles. I don't know if you've had a different experience. Yeah. And so, and then there's also the drama around the battery life. And I can't remember, I think our batteries are guaranteed for 200,000 miles. I had a Toyota Camry hybrid, a Gen 1, and I drove it for 200,000 miles. I could not detect any deterioration of the batteries. And I got more stories around that, but I don't want to take everybody's time. Other questions? Okay, well, I appreciate everybody staying around. Hopefully you found it informative.
Thank you. Be sure to push your chairs in. I'll